Well, hello, and thank you for joining us on Stars, Cells, and God today. I'm Jeff Zweerink, and I'm joined here in studio by President and CEO of Reasons to Believe, Dr. Fuz Rana. We're going to be talking about woolly mice and mantis shrimp. Fuz, good to have you in the studio today.
Jeff, thanks.
So I will just go ahead and turn the floor over to you. I'm curious to know what woolly mice has to do with God here. So.
Yeah. Aren't we all? But, Jeff, just to kind of transition us into the discovery, I don't know if you remember these TV commercials. They were prominent in the 70s and in the 80s. It may be a little bit.
That'd be in the ballpark of where I would remember. So.
Okay. What it was about, the commercials were for Life breakfast cereal.
Okay.
And there were two older brothers, and they weren't sure if they were going to like the cereal, so they gave.
Let's tell Mikey, his brother.
Yeah,
I do remember
the younger brother, right? And then of course he likes it. He likes it, right?
Right.
And that commercial, highlights, I think, a very important truth is that little brothers are the test subjects. In most families. I was an older brother, and if there was, knowledge to be gained through trial and error or some kind of proto-experimentation, my little brother was involved in some way, shape, or form.
What was the age gap, if you don't mind me asking?
3 years.
3 years between you and your younger brother?
Yeah.
Okay, yeah, because between the three of my brothers, there was 10 years, and so we didn't do quite so much of that, but yeah, you're right.
Well, and I, even though people claim that Christianity is the basis for the birth of modern science, I think actually it's little brothers. Oh, yeah. If it wasn't for little brothers, there would be no scientific method, because little brothers are the ones everybody experiments on. And if there's a analog in science to little brothers, it would be mice. Right? Hey, if you want to know what happens if you do X, try it on a mouse, right?
Right.
And that's what the basis for the discovery I want to talk about, which was the creation of woolly mice by a company called Colossal Bioscience. And this is
I presume woolly mice are not normal mice?
No, they're not. They're mice that have been gene edited to have some of the traits of a woolly mammoth.
Oh, okay.
Right. And so here's a picture of, just for fun, of a woolly mouse next to a regular mouse. And they're actually quite cute and adorable, very fluffy and hairy little mice. But the idea is that behind this work is to determine whether or not the ideas that this company has for resurrecting the woolly mammoth would actually work in a laboratory setting.
Okay.
And there's actually a whole area that's emerging in biotechnology called de-extinction, right? Where the idea is that we can now take advantage of the advances that we have in ancient DNA analysis, the isolation and the characterization of ancient DNA from fossil remains. We can use advances in gene editing, stem cell biology to actually resurrect species that have recently gone extinct. So
this doesn't bring to mind Jurassic Park or anything like that in
your
mind,
no, it's very much, in the fold of the Jurassic Park movies, but it's actually work that's serious. This is something that's actually achievable.
Well, that's what strikes me. Is I remember when Jurassic Park came out, it was a neat movie, but it was like, okay, this is a stretch scientifically. The fact that we're seriously considering is a testament to how science has advanced a lot since then.
Yeah.
So.
Well, and again, there's a number of life scientists and biotechnologists that are actively working in this area of de-extinction, where they have identified a number of different protocols that could be used to de-extinct animals that have just recently disappeared. And there's a long laundry list of animals that they think could potentially be candidates for de-extinction, including the woolly mammoth. And there's actually a lot of reasons why people want to do this, even though, the image of Jurassic Park comes to mind, and this whole idea, just because we can doesn't mean that we should, right? There's actually good reasons to do this, not only because we can, but there are reasons why people think we should do this work. One of them is just the cool factor, right? That this is actually a technology that we could execute, and wouldn't it be neat to be able to interact with a woolly mammoth one day, right? So there's that cool factor, but kind of leading or flowing out of that cool factor is that by doing efforts in de-extinction, it actually calls attention to conservation efforts. It's a great way to really publicize to people the idea that we are living at a time where a lot of species are endangered, and that we need to step up conservation efforts. And so by doing work that's high tech, that's really kind of sexy in terms of de-extincting animals like the woolly mammoth, we actually are calling attention to the need to invest more resources in conservation biology. Another idea is that this also allows us to promote biodiversity, that we're seeing biodiversity loss in the world because of extinction. Some people think we're on the cusp of the 6th great mass extinction, triggered largely by human activity. And so we want to preserve biodiversity, and we've lost biodiversity. And so can we take animals that have recently been lost and bring them back to preserve biodiversity, and to some degree kind of undo our ecological sins? At least that's how people would justify this, that they even see it as a moral imperative. Look, we're responsible for these extinctions, whether intentionally or unintentionally, and if we can do something to reverse it, then we really ought to. Some people see this as, particularly with the woolly mammoth, as a way to maybe reverse some of the effects of climate change. So for example, in Siberia, in parts of Canada, where the woolly mammoth existed until about 4,000 years ago or so, when the creatures went extinct in that neighborhood, that was actually a highly productive grassland. And people believe that the woolly mammoth actually played a critical role in maintaining the grassland. And when they were lost, that grassland converted into tundra, which is much less productive land. But trapped in that tundra, in the permafrost, are high levels of greenhouse gases, CO2, maybe even some methane. And as the climate changes and the world begins to warm a little bit, there's melting of the permafrost, which then causes greenhouse gases to no longer be trapped, and that actually, feeds the pernicious cycle of climate change and global warming.
But does it? I mean, so just I'm missing something there, because it seems like, how do you have would the permafrost be underneath the grasslands?
The grasslands are gone.
No,
so it's
so
tundra.
when they're grasslands,
right? Well,
would the permafrost have been underneath? It seems like if you convert it into grasslands, that's going to melt the permafrost and release greenhouse gases.
It's underneath it. So so the reason why people actually think the resurrecting the woolly mammoth would actually help by converting the tundra to grasslands is an experiment done by these two Russian ecologists called Pleistocene Park, where they took a tract of land in Siberia, and they introduced large herbivores that are not native to the tundra into the park. And the animals, as they churned the soil on the tundra, actually exposed the deeper areas of the soil to the cold climate, which caused it to freeze at a greater depth. And so the soil temperatures and the depth of the frozen areas in the Pleistocene Park, it has lower temperatures than outside the park, and it has a deeper level of the cold temperatures are deeper into the soil. So the thought would be, if you could reintroduce woolly mammoths, which are much more massive and are going to churn the soil even to a greater degree, it might at least deepen the permafrost, and maybe even revert the lands back to grasslands.
Mm-hmm.
And so this is actually what motivated the formation of a company called Colossal Bioscience.
Okay.
And there's some prominent biotechnologists that are part of this. George Church at Harvard University, Beth Shapiro. I think she's at one of the UC schools. I don't remember if it's, I think it might be UC Santa Cruz. But there's also some very large investors who see commercializing de-extinctions as actually valuable because it's going to create biotechnology that's going to be transferable to other areas of medicine and science. And that's how they see this being profitable. But they all are serious about executing de-extinctions, and the primary animal that they're focusing on is the woolly mammoth. And so there are good reasons why they want to do this. Now, the approach that they're looking to take is one in which we have the genome sequence for the woolly mammoth. You can't really truly resurrect the woolly mammoth, but what you can do is resurrect a proxy for the woolly mammoth. You're trying to resurrect the traits of the woolly mammoth. And so their idea is that we've got...
So if you have the genome, why could you not resurrect the woolly mammoth? It seems like...
I'll explain that to you in a second.
All right.
Yeah, but it has to do with the need to clone and having a surrogate to carry the quote unquote woolly mammoth proxy to full term. Right.
So is that you can't do it immediately? I think at some point in time, the hope would be that you're making these animals that could be a viable, livable species. At that point in time, they would no longer be surrogates. They would actually be woolly mammoths?
Right. Well, I mean, regardless of what animal you're trying to de-extinct, the nature of the methods, and there are a variety of different methods that are being explored, are not going to resurrect the animal itself. They're going to actually resurrect the traits of those animals, and you're going to be creating a non-natural, novel life form that has those traits, but is not actually that animal. So they refer to these as proxies for the woolly mammoth, proxies for the dodo bird, things like that.
So is that just saying that there's something about the animal that is not inherent in the DNA itself? There's something else about the animal that whatever cell you're using, those sorts of things has a contributing factor. Okay, that makes sense.
Yeah, but we've got the high-quality sequence for the woolly mammoth genome, right? And this is coming from 2 specimens that date around 4,000 to 5,000 years. And the closest, by analyzing that genome, the closest extant animal is the Asian elephant.
Okay.
And so you can do a comparison between the woolly mammoth genome and the genome of the Asian elephant and identify genetic differences that then become the target of the resurrection process. So the researchers have identified about 1.4 million genetic differences, right?
Okay.
But of those genetic differences, they've been able to identify a number of genes that they believe are responsible for the cold adaptive traits of a woolly mammoth. And so those become the genes that you want to target. So the idea would be that you would take a skin cell from an Asian elephant and convert it into an induced pluripotent stem cell. Then you could gene edit that to introduce woolly mammoth traits into the Asian elephant. Then you could use that nucleus and transfer it into the egg, an enucleated egg of an Asian elephant. So this would be essentially the cloning process. Then you'd create a clonal zygote that could then replicate into form an embryo that could be implanted into an Asian elephant and give birth to a version of an Asian elephant that would have woolly mammoth traits.
Okay.
That would be...
Okay, so I get what you're saying. So this isn't like we're building the genome of a woolly mammoth. We're taking an Asian elephant and making it more like a woolly mammoth.
Right.
Like your woolly sheep or your woolly mouse here. It's a mouse, but it's got
Right.
this key. Okay,
Yeah.
that makes more sense.
Yeah. So the idea would be this is a proxy, and what you're resurrecting are the traits,
Right.
not the actual animal.
Okay.
Right. And then the idea would be you'd have these Asian elephant versions of a woolly mammoth that you could let loose in the tundra, and what could go wrong, right? Right. But
well, at least they're not going to go out eating people.
yes.
Most likely because they're herbivores.
Yeah, that's not going to happen. But so interesting idea that is actually technically feasible. The problem is to try to work out the methodology on an Asian elephant is problematic. For one, they're endangered species.
Right.
So people frown upon experimenting on endangered
Makes
species.
sense.
Number two, the gestation period is 2 years or 22 months.
Right.
That's a long time to wait for an experimental result.
Yes.
Mice, on the other hand, the scientific little brother, right? Their gestation period is 20 days.
Okay.
So you can do a whole lot with mice just to work out the protocol. And so that's the whole point of this particular study was essentially, can we actually do what we think we can do in the woolly mammoth, or to resurrect the woolly mammoth? Can we work that out in mice? And so that's why Colossal Bioscience essentially focused on the creation of a woolly mouse. And this is a slide that I've taken from the Colossal Bioscience website that shows the woolly mammoth and the woolly mouse, where they focus primarily on hair genes, on a number of genes in mice that correspond to genes in the woolly mammoth, where those versions of the gene produce hair that is going to give that woolly appearance, right? And there's 7 or 8 genes they identified, and they
and this was all kind of motivated by the cold adaptation,
right.
Not so much a understanding how it all works there, but figuring if you've got more hair, you're more cold adapted, you're at least going to be able to do something.
Right, and the hair has different types of properties that make it such that not only is it a hairier animal, but it's going to trap warmth on the skin. And they actually published this work right now as a preprint in the BioRxiv website. But what they did in the study is they explored 2 different ways to do the gene editing. One involved essentially doing the gene editing at the clonal zygote stage. So here you would take the induced pluripotent stem cell that would, from an Asian elephant, transfer the nucleus into an enucleated egg. And as you're doing that transfer, that's when you hit it with the CRISPR gene editing package. And so you do the gene editing simultaneously with the formation of the clonal zygote.
Okay.
The second point, or second stage, is they actually created the clonal zygote, and then they prior to that they did the gene editing in the induced pluripotent stem cell. And then once the clonal zygote formed, they took some of those embryonic stem cells and introduced them into the fertilized egg of an Asian elephant. Okay. And they looked to see which approach would give you the best results. So they were working out really what is the best way to do the gene editing, what stage in development, and again identified a number of genes, and the net result is that they were able to successfully produce this woolly mouse.
So what, you mentioned there were like 1 some odd million differences between Asian elephants and the woolly mammoth. Do they have a sense of how many of those they could do? I mean, I'm presuming doing the gene editing for 1 million is much harder than for 1 or 2.
Yeah. I mean, I don't know what the exact limit is, but I'm of the impression that with CRISPR gene editing in one fell swoop, you're looking at about at the most 50 points in the genome that you can edit. I think much beyond that, I don't think it's going to work. So there is a an upper limit to
Yeah.
how many changes you can make simultaneously.
Does that also then apply to I could do it once and twice and can
Yeah,
you
but
additive or is
I think
it seems like the more you do it, the more you're working against statistics going
yes,
or randomness
yeah.
going
I think
afoul,
I think there's a limit to. Yeah, you probably are really looking at one shot.
Okay.
At least with current technology. In fact, it's interesting. The title of the paper is a multiplex edited mice.
Okay.
And multiplex means multiple edits at the same time. Right. And so in this study, there might have been 7 or 8 genes that were selected to be edited to convert the woolly mammoth or the mouse version into a woolly mammoth-like version, right? So, this is interesting stuff, right? And there's very good reasons to do this, but, I've am working on a manuscript right now for a book called Should We Play God? And this is one of the chapters is on de-extinction. And, what is a proper Christian perspective on this kind of work? And so what I argue in the book is that we could sit here and debate the ethics of this all day long, but really this is ultimately, for a Christian, a deeply theological question, right? Should we play God is really a theological question. And in the book, I take the approach of looking at a theology for biotechnology based on the 4 main stages in the Christian story: creation, the fall, redemption, and consummation. And very quickly, I just point out that look, as people made in God's image, we have certain responsibilities. We are to be caretakers of the planet. We've been given, we're to reproduce and fill the earth. We're to promote human flourishing, and at the same time, we are to have the authority over creation. We are rulers and caretakers of creation, right? So we are co-creators, co-rulers, and co-stewards. And in that trifecta of responsibilities, I think we have the authority given to us to actually exercise control over the creation in a way to promote stewardship of the environment, stewardship of life on the earth. We also have the responsibility to promote human flourishing. And I think oftentimes people see human flourishing at odds with environmental stewardship. And in fact, they're not. That what we do to take care of the environment actually helps to promote human flourishing. So when you look at de-extinction efforts from the lens of creation, there are very good reasons why we should be excited about this as Christians, because it's a way for us to undo some of the damage that we have caused, allowing us to, preserve biodiversity, maybe even recover lost biodiversity. It's a way, if we do it responsibly, to maybe help mitigate some of the damage to the environment that we've caused through these extinctions, right? And it falls entirely within our purview as people who have dominion over the creation. So I see this as something that aligns with our with the mandate that we've been given as image bearers in light of creation.
No, that makes sense, and I would agree. One of the questions, just as I've been thinking about new technologies, and ultimately this was driven by kind of foraging into AI and what do we do with it, is I've become aware that there's the technology and what it can do, and then humanity and what we will do with it. And I'm looking at this, and just maybe we'll run into problems or we'll find issues that this doesn't work, but in principle, this could be used to do something that will be of great benefit. But I'm also aware of how many times 2 things come into play. One, go back and look at the car when it first came out. It's like, look at all the places we can go, things we can get to, so many things that we could do with the car that we couldn't do otherwise. And largely I think this will play into the second part. I'm going to ignore the second part for a second. But due to the fact that we just didn't consider that, when you're burning fuels, you're generating greenhouse gases, because they were small, didn't have to worry about it. As we adopted that technology and grew, now we're faced with an issue of just our day-to-day life of using this technology is what's, I don't want to say destroying the planet. I think that overstates the case, but almost as because we didn't know side effect is what causes the problem. So there's that question I have. I'm curious your response. And then the other question I have is, I don't think it was all entirely benign. I think there was mismanagement of that as well. So for everything you say we could do with that, I also have to think, what else are people going to do? Because we do things to excess, we do things in perverse ways, and this strikes me as a technology that is increasingly, because of its power and what it could do for good, it also has that similar for bad. So I throw those two questions to you.
Well, that's a great question, because it brings us really to the second movement in the Christian story, which is the fall. And I think when people ask the question, well, should we play God? In the back of their mind, they're thinking, well, what about the effects of the fall, right? Which was that as Adam and Eve rebelled against God, it introduced sin into the world, or at least into humanity. Moral evil and moral corruption now became part of our identity. And that means that, our relationship as a result of the fall with God is broken, with others is broken, and with the creation is broken. And so instead of being able to be good rulers over creation, instead of being able to be good stewards over creation, creation is cursed now because of us, right? We are incapable of having that right relationship. We lack wisdom, right? There is a propensity in each person to engage in sin. So when you talk about emerging biotechnologies, there really is concern about, rightly so, what is the impact of our sin going to have as we develop these powerful technologies? Could you use this kind of technology as a type of bioterrorism where you unleash, these animals that you're bringing back from extinction are going to be introduced into ecosystems that are not like the ecosystems that they disappeared from. And so what happens, right? Even if you have the best motives, things could go wrong, right? You're not introducing the woolly mammoth back into a grassland. You're introducing it into a tundra. Could there be unexpected effects? Or could you deliberately resurrect an animal and introduce it into an ecosystem because you anticipate it's going to cause havoc, a type of bioterrorism, right?
That's a good way to fight against other or a good but short-sighted way to fight against other enemies. Yeah, well, it could come back, literally and bite you, right? But so this idea of the fall is a very real problem. Now, a lot of times I've seen when people engage biotechnology from a Christian perspective, it's always in the context of creation and fall. And one of the things I think is also important is the idea of redemption, that as Christians we are redeemed. And as redeemed people, we are recovering that the damage of sin is being undone. Our relationship with God is restored. There's the means now through the power of the Holy Spirit to restore relationships with other people and with the creation, that we have resources available to us, right? The wisdom from Scripture, the wisdom from that comes from God, the wisdom of a godly community seeking to honor God, right? And so there are very good, because of our the impact of the redemption, as Christians, we uniquely, I would argue, have capabilities to step in and manage this kind of emerging technology in the best possible way. So, if you ask me, am I in favor of de-extinctions? My response at this point would be, I'm not. I think it's fascinating science. It's fun to think about what it would be like to interact with some of these extinct creatures. But I think
it's incredibly naive to think that you're going to release animals into the environment and it not have unintended consequences, because ecological systems are incredibly complex. You're also, again, as I mentioned, introducing these animals into novel ecological systems, not into the ecological system they disappeared from. Because of their disappearance, the ecology changed, and so you're not ever going to, it's not identical. Plus, there are very real concerns about animal cruelty. You know,
from people to people treating animals cruelty,
no,
or
just
animals just destroying other
well,
animals?
just the whole. I mean, we know that cloning is not perfect, right? And that clones suffer from health effects of the cloning. We're getting better at cloning, but clones are generally not understood as being healthy. So, you know, are you going to be creating these hopeful monsters that are really suffering, you know, through the scientific process of figuring out how to create these kind of animals?
Oh, okay. So just the process of doing it is what you're I see what you're saying.
And then, you know, elephants are highly social creatures, highly intelligent creatures. If you have woolly mammoths, are they going? They have to be in a social environment. You've got to create herds of them, and how are they going to react with one another? You know, is the surrogate going to properly raise the woolly mammoth looking Asian elephant? So these are some very real concerns. I'm not a soft-hearted animal rights activist, but I think as Christians, part of our stewardship is not to abuse the creation, and that, you know, Scripture instructs us to care for animals, right? They're not the same as human beings, but they should be afforded respect and dignity, and we don't want to introduce undue suffering in animals. And so I think, you know, I'm not really, there's other areas of biotechnology I'm very excited about. This is one area it's hard not to be interested in it. It's hard not to think that it's cool, but I'm not sure that I'm on board with these types of projects.
Well, and, you know, that aspect of, you know, creation, fall, and redemption as it plays out here is one of the things, you know, I'm just looking at, you know, global climate change, global warming, you're looking at social media, all of these things, even the way COVID was handled. There seems to be a propensity, at least today, I don't know whether, you know, go back 60, 70 years ago, I don't know whether it's true, but at least today, that it's whatever the flashiest issue is what gets the attention, as opposed to thinking about the situation as a whole. And, you know, this is where that discussion in my mind of the car comes up. It's like, you look at the car and what it can do, and it's great, but if you don't understand the entire impact, you could very well be making a bigger problem later than the one you're solving today, even in the best of circumstances. And that seems to, that's a question I would have here. And, you know, your description there alluded to it or articulated some of the points is, you know, how do you know that this creature is going to be able to survive? Will it interact well? It seems like there's part of that requires, given how big of a thing it is, we ought to make sure we understand it much more thoroughly than we do. But I kind of have a little bit of a fatalistic attitude towards that, because that requires everybody to be doing that. And, you know, I might get everybody in my sphere decides, oh, yes, that's the right way to do. But who knows if this person in the other country decides that. You know, we all don't operate from the same worldview. And so that's what makes me a little more hesitant, not just here, but in a lot of the technologies we're developing.
Well, you know, and this is why I think as Christians, it's really incumbent upon us to understand the science, to understand the ethical debates that are happening by people who are experts in the science, as well as experts in bioethics. Even if we see that debate happening in a secular framework, it's worthwhile understanding it. And then we need to step in and engage our culture from a Christian worldview perspective, where people are going to respect the input we have because they understand our motives are pure, that we understand the science, we understand the ethical concerns, right? And it's even important for young people who in the church who have an orientation towards the sciences, who like biology, who like engineering, to get in, to actively pursue careers in de-extinction where they can become that Christian perspective, a knowledgeable Christian perspective embedded in the field that can help shape the direction of the technology, or help us to determine even if this is the technology that we need to pursue, right?
So there's another question I have in this that, and it goes back to kind of the fatalistic, or fatalistic's not the right word, but not optimistic view of this, and that, when I was thinking about artificial intelligence, even if I could get, like the United States to say, hey, let's hold on this and make sure we're actually implementing it well, because it's going to cause a lot of damage. There are other countries around the world who are all in on this, and so if we do that on a global stage, we're setting things up, because not all worldviews approach the world in a way that is healthy for the rest of the world.
Right.
And it seems to me, and I haven't figured out how to articulate it well, but it does seem to me that as Christians, I think we are well served by trying to articulate not just what Christianity has to say, but why you should want Christianity to be true. Because I don't see naturalism, if you flesh out naturalism, where everybody is a naturalist anchored in understanding the worldview of naturalism, I don't see how this works well.
Yeah. Well,
because it doesn't. But at least Christianity, if everybody understood Christianity and was seeking to do that, it will work. It has the potential to work out well, despite the fact that we are still in a fallen world.
Yeah. Well, I mean, if you're operating within a naturalistic framework, you're dealing with some kind of utilitarian ethics, right? And, the greatest good for the greatest number, right? Which means that people that are marginalized don't count in a utilitarian framework. It's okay for a few people to be exploited if a large number of people are going to benefit. It's okay for a few animals to suffer if it means that we can we can mitigate the effects of climate change, right? Those are the types of reasoning that go into utilitarian ethics. It's not you're determining the value and the rightness and the wrongness of an action based on the consequences of it. But many times you don't know what those consequences are, or why should one set of consequences be considered to be the preferred set of consequences and another set not. So you have an ethical framework. It's just, in my mind, one that can lead to some really horrifying outcomes if you take it to its logical conclusion.
Well, and I'll throw this argument. I'm curious, just to get your feedback here. It seems to me that the problem is worse than that, because in a naturalistic worldview, it's not clear to me that there are established ethics.
Right.
So the idea, if you're going to try and do things well, you could end up in utilitarianism. But I don't see how Hitler is outside the realm of a good naturalistic ethic.
Right.
You might,
yeah.
In Christianity, you can't get there and ever say that's a good thing. Whereas in naturalism, it seems perfectly consistent with the foundation of naturalism. You can put, that's not to say somebody who's a naturalist can't be ethical, and that's not to say you can't have naturalism and have an ethical society, but I can be perfectly consistent with naturalism and seek to dominate the world.
Yeah.
So I think it's even worse than just a utilitarian ethic.
Right. Well, and maybe this is building off your point, maybe it's not, but even from a naturalistic standpoint, you might even argue that the value of these animals that have gone extinct is greater than human values, or the value of humanity.
Right.
And gosh, we're the villains because we caused these extinctions. So you could argue that let's go ahead and resurrect them, and if they cause havoc to the environment and end up compromising human flourishing, so be it, right? That's just the, why is that a bad thing necessarily, right? So, I agree with your point. I think, this is something that is amazing to me, is that the Christian worldview produces an ethical system that is so robust, even though it's based on, the biblical text that is 6,000 years old or something like that,
right?
Or at least some texts that are that old. Texts that were presented in a pre-scientific age. It's robust enough that it can actually guide us, in the 21st century. In scenarios that would have been completely unanticipated by anybody, just prior to just even even 50 years ago, right? It's remarkable to me, and it really is this, going back to this idea that we should want Christianity to be true, because I think the ethic that emerges out of Christianity promotes science, it promotes technology, but it recognizes our limitations as human beings, our short-sightedness. It also recognizes that we could easily exploit marginalized people. So it really ensures an ethical framework that, I don't know that there is a Christian position on any biotechnology. It's something that could be debated, but that debate is with the eye towards doing the best for all people involved, for the planet, for the animals that are involved, right, with an idea of promoting justice. In a sense, you could say Christianity is good. It's not, even if it's not true, it's still good. Yeah. But I think it's true and good.
Right. Well, and I think this is a place where, a comment Hugh made has kind of profoundly changed the way I thought about or think about these sorts of things, is that it's not clear to me in a naturalist or a Buddhist or a whatever scenario where you actually have a workable solution that takes care of humanity and the planet and the animals.
Right.
If God is who he says he is, that solution, we actually have a confidence that the solution exists.
Yeah.
Now, whether it's easy to find, hard to implement, that's a different question, but the God who created us and the God who created the planet are all, there's a unity about how all that works and a purpose that it's going somewhere. And so there's not only does your ethical system that you've described work over the many, many years, it offers a hope that I don't know that any other worldview does.
Yeah, I agree. So. Yeah, well, Jeff, I think we've exhausted this, maybe more so.
Well, no, this is a good discussion. I was kind of contemplating here. Do we just continue to have this discussion, or do we actually move over to the other one?
Up to you. You're driving the
good.
car.
I'll tell you what, we've got a little bit of time. I was talking about mantis shrimp, and this is not so groundbreaking, and if you will, as creating new mice in the lab. That's kind of cool. But I have just been, over the last 10, 15 years, as I've been looking at it, amazed at how often we go out and look at nature and things that are common or, oh yeah, that's the way nature works, and there's this elegance and sophistication that rivals or that only our sophisticated scientific minds even begin to understand what's going on. And the mantis shrimp is one of those. I think I've talked about shrimp in other places, but the particular aspect of the mantis shrimp that I wanted to talk about is it's got this dactyl club, and I don't know why the term dactyl is just outside my vocabulary, but nonetheless, it uses this club to go and crack shells of other creatures. I've been thinking about young Earth creationism, and the idea of predation and how well designed this is just strikes me as an argument that death before the fall is not nearly as detrimental or nearly defaming of God's character as young Earth creationists, because God seems to have written a lot of creatures that have very well designed things. But so this creature is 3 to 18 centimeters in size, has this club that it can crack things over repeatedly. Happens on the order of a few microseconds, or a few millionths of a second, does very little damage to the club. And that's the remarkable part, because it's a biological material, so it grows a shell, but yet using this thing, it very repeated blows, very rapid blows that deliver incredibly strong forces considering. I think it said it's on the order of 1,500 newtons, and this is the downside of the metric system, is that we talk in pounds and stuff like that. But that is a force that's thousands of times more than the weight of the object itself. So imagine whatever I can do to be able to deliver a force 1,000 times my mass, which is substantial. That's a remarkable thing for this organism to do, and it generates a symphony of blasts or impacts that last over a few nanoseconds up to the scales of a fraction of a second. And it basically, as it hits, it produces these cavitation bubbles. These bubbles form, and as they collapse, they just do damage to the surface there. And so it's really a remarkable way this happens. And these blows generate shock waves, and these shock waves have energies up in the megahertz range. And so that's what does all the damage. And what's fascinating about this is, as people were looking at this, is like, how does this club, which is made out of basically shell material, it can break other shells, but yet it's not broken or it sustains very little damage. And so they had this idea, maybe it is actually working like these metamaterials we make, where we design materials that have these bizarre physical properties. Among these metamaterials are materials that have negative bulk sorry, I hate that when a word goes out of my hand. Negative bulk densities is density and bulk moduli. There we go. Normally when bulk modulus is the measure of when you press on something, how much does it reduce its size, if you will. Well, if you have a negative one of these things, as you push on it, it actually expands in size. Negative effective densities. You see, those are not common. They sound bizarre because they are bizarre, but yet we can build materials that with periodic structures we can make at least over a certain range of inputs where they behave in very counterintuitive ways. And that's what people were asking is, does the club, this dactyl club of the mantis shrimp, actually have these properties of these metamaterials? And as they were investigating, what they realized is that the club has kind of 3 layers to it. It's got a relatively thin impact surface, so that's what's actually hitting. Then it's got, it's about 700 micrometers. Another 500 micrometers is the impact region, and then it's got this periodic region. And this periodic region is in the shape of a Bouligand arrangement. And I had to look up what that was, but it's basically, you've got these colloidal fibers that are lined up in a herringbone pattern, and each layer is rotated to the one below it. And in the particular shrimp, it's 2 to 6 degrees with every layer, and it's in this herringbone structure. It's just basically chitin fibers, so nothing particularly fancy, I don't think, about the fibers themselves. But because of this arrangement of fibers and the way they're in the herringbone pattern and then having this rotation, they were actually doing some very sophisticated laser ultrasonic imaging of the shell. And what they recognize is that this periodic structure basically sets up a band gap structure in there so that as an impact comes in, generates shock waves or sound waves, and those are longitudinal waves. But the periodic structure does things so that certain frequencies, certain bands of frequencies cannot pass through. And what it does is it basically, as the waves go through this periodic structure, there's destructive interference for those wavelengths that cancels them out, does 2 things. One, it cancels them out, so you end up with this gap where it doesn't have. And then beyond that, it actually distributes, or as it's absorbed in this structure, it distributes the impact over a much larger area. So whereas it can hit a small region and cause a lot of damage, the impact to the shrimp's club is distributed over a much larger area, and so it causes very small amounts of damage, minimizes the amount of cracking and these sorts of things. And it's just, what I find fascinating about this is not that we've gone in and understood how do these shrimp clubs work, these mantis shrimp clubs work, but the mechanism by which it's working are materials that we theorized 60-ish years ago. Back in the early 2000s, we started being able to make, and as we've made, they're very bizarre, hard to manufacture materials because they require very detailed or precise placement of materials at very small scales. And yet we see these regularly distributed through nature. In fact, as I was looking up this Bouligand arrangement, the Wikipedia made this. They're frequently found in naturally evolved materials, which I thought, that's an interesting way to say that, especially when we go look at the mantis shrimp. I love the way the authors of the article in Nature described it. It says, a major contributing element to the dactyl club's strike power is its hierarchical design, made from a limited but exquisitely tuned arrangement of mineral and organic materials. That here you have these scientists looking at how it's arranged, saying it's naturally evolved, we see it all the time, but it's exquisitely tuned.
Yeah.
There's part of me that as a Christian apologist wonders that if we just kind of quit making this such a big deal and let scientists describe things the way they would, we'd get a lot more language like that. Because I think there is that elegance and beauty and design and exquisiteness, but so often it gets tied up where if you say something's designed, oh, that's helping the creationists, if you will. That I just see a signature of God's work in creation, that the best things we can make, we find regularly in nature, and we see their fine-tuned nature there, and yet they work beautifully for what they are. Yeah. And there's so many more questions of scientifically. It's like, does this arrangement, if you're close, does it work? Or is it kind of as a phase transition and where it works or not? I think you're going to find a lot more that it really is exquisitely tuned, or else it just doesn't work. And so I just thought that was a fascinating discovery of a cool creature that we see God's design, God's fashioning of animals, and it just seems apparent in the way it plays out. So
well, to build off of the point that you're making about the incongruity in the language between, evolution evolved these designs and, look at the fine-tuning and the exquisite nature. I mean, you just have to marvel, first of all, at the ingenuity of the design and the fact that how much effort does it take to even understand the design, let alone execute the design ourselves. But, when you read people that are considered to be the more prominent evolutionary theorists, they will tell you time and time and time again that evolution does not produce optimal, well-designed structures.
Okay.
Right? They go out of their way to point out that evolution produces inherently flawed designs that are imperfections, and that if my imperfections are a little bit less than your imperfections, I survive. Right? That evolution...
It's kind of like a huge kludge job almost.
Yes,
like...
yes. That's what evolution produces. In fact, I remember having a conversation with Ian Tattersall, and he just said everything in biology is a kludge job. And what they mean is that, look, you start with a biological system, and that design is constrained by evolutionary history. You can only evolve that design in certain directions, and you are cobbling together new systems that are constrained by your past systems. It's not an optimal system. It's not a well-designed system. So if this is how you understand the evolutionary process and the types of designs it produces, you can't really make the claim that evolution is producing these elegant designs. That's incompatible. Even though I see that phrase used a lot in biomimetics, it's incompatible with how evolutionary biologists see the evolutionary process. And so if that's the nature of the evolutionary process, you might expect that once in a while there might be designs in biology that could inspire technology.
Right.
But the fact that you have biomimetics as this discipline,
Right.
where it's one of the more exciting areas and productive areas in engineering today,
Right.
is completely incompatible with an evolutionary view of life. It really fits with a design or a creation perspective.
Well, and even part of that, this is kind of my comment, is I wonder if making science kind of the battleground, and there are organizations who've done it differently, but by making, there's this kind of battle between science, creation and science, if you will, that it's made the environment more hostile to recognizing, allowing people to speak freely about what they see, because you're kind of worried about if I say, oh, I found the mechanism, or I found how evolution produced this, you got a group of people saying, oh, you don't think God, there's a whole what you believe about God that plays into that. But on the flip side, if you're just investigating something and there's this fascination and it's very well designed and exquisite, and you say that, you're also giving fodder to the other side. And it's like, one of the things that I really have liked about RTB and what has drawn me to it is there's making an argument of, oh, here's the case, here's how I think you can do that, but really is going out and saying, there's just a lot in creation. Let's just study and figure out what it is, and hopefully allowing the environment in which science and Christianity interact to be amenable, so that these things naturally show up. I mean, I'll be a little bit candid here. We were getting ready for the show, and I'm kind of like, oh, what's out there? And I ran across this. I'm like, oh, this is cool. It wasn't like I had to search long and hard to find interesting stuff to talk about. It's just there pretty regularly. It's just a matter of, do I want to go and invest the effort to develop into a cogent way of articulating it?
And I think that there's an enormous opportunity in biomimetics to really advance the design argument in a fresh way, right? And it just highlights just the elegant designs, as you pointed out, that you see throughout nature, throughout the living realm. And the more that we understand these designs, the more remarkable they are.
Well, and I think there's a place too where, if you come into it with a design mindset, the questions you ask could very well are likely going to be more helpful in understanding what's going on.
Right.
Because I think there are places where, just the adaptability God's built into creation allows creatures to change and adapt to the environment. I don't know that I'm going to look for extraordinary means to make that happen. But, in this particular situation here, you've got these periodic layers that are rotated at certain angles. Now, a whole slew of questions come into my mind. What happens if they're rotated at stronger angles, lesser angles, if the fibers are thinner or thicker? Is this something that there's this broad plateau? When you get on the plateau, you get the behavior? Or is it more like, no, you got to get to the top of the mountain, and the mountain's pretty steep?
Right.
These are questions driven by how I think about how God would create,
right,
and what does that show in there. And so it's actually opening up good scientific questions instead of trying to explain, how might this have just come about by random processes. It gives me a different set of questions. And I stole that argument from you, so I'll give you credit for it.
Well, thank you, but not necessary. But oftentimes you hear this challenge that if you adopt a design perspective or a creation perspective, you're just shutting down scientific inquiry. I think the answer is absolutely not. You're just asking a different set of questions maybe than a naturalist would.
No, that's a good point. Any final comments you have? It's like I said, I find this stuff pretty interesting, and the way it plays out. But
I think if there's a theme that we see from these two discoveries, it's really this idea that there is this interesting interplay between technology and between the design of biological systems, right? And as we try to design, novel, non-natural life forms, the amount of effort it takes to even to create a woolly mouse is enormous, right? And it just highlights really the complexity of living systems and the sophistication of living systems. And so, there's this very interesting interplay, between designs in biology and technology. And as human beings, we are now becoming creators ourselves. And through that process, I think it really highlights just how amazing God's handiwork is.
Well, if I could throw in one comment, that your comments there spurred a thought. I was talking with my wife this morning, and I appreciated that Luke is the only person that kind of introduced in his gospel what he's doing there. He said, I'm doing this to give an account. All the other gospels just kind of start, if you will. And in our conversation we were having as we were walking, that it struck me, it's like, you've got, in some sense, one gospel would be adequate to tell the basic message of what we need to know to know God through Christ our Savior. But God gave, there's a gospel which is written to the Jewish people to establish that Jesus is the Messiah described in the Old Testament. There's a gospel written to the Gentiles to give a historical, chronological account of all the events that happened. There's John's gospel, which has a different focus. There's Mark's. That God didn't just say, well, here's the basics of what you need. He gave the basics and revealed himself so, in a way I would say is so big that we could never exhaust understanding understand all of his revelation. And if that's true in Scripture, I would expect it to be true in creation as well. And that's just, your comment reminded me of that thought, that I tend to think of God kind of small in what he does, and he's generous and abundant in who he is. So
well said.
Thanks. Well, I want to thank you for joining us today. I want to encourage you to join the discussion in the comments below. Remember to like this video, subscribe to get new content. Remember that new episodes of Star Cells and God drop every Wednesday on YouTube and your favorite podcast app. Share this video, have a great discussion with people around you, and remember, the more we know about science, the more reasons we have to believe.